Hi friends, my name is Chaitanya Tambe and I am in 9th standard. In this video, I am going to show you Hooke's law. Hooke's law is a law of physics that states the force needed to exchange the compress and string by some distance scale linearly with respect to the distance, that is Fs is equal to kx, when k is the constant force character of the spring and x is the small compared to the total possibility determinant of the spring. This law needs after 7th century British physicist Robert Hooke. He first stated the law in 1676 as a Latin agreement. He published the solution of his agreement in 1678 as Utististan sequis. So the force or the extension proportion to the force, Hooke stated in the 1678 work that he was arranged the law already in 1660. Hooke's equation hold in a many other simulations when the elastic body is deformed, such as wind blow on the tail, building and a muscular planking strat of the gilt, an elastic body or material of which this equation can be assumed is said to be linear elastic or Hookean. Hooke's law is only a first order linear approximately to the real response of string and other elastic bodies to applied force. It must eventually fall once the force extends some limit, since no material can be compressed beyond a certain minimum size of structure beyond maximum size without some predetermined determined or change of state. Many material with notice divide from Hooke's law well before notice elastic limit are reached. On the other hand, Hooke's law is an actual approximate or for most solid bodies as long as the force and the determination are small injured for this reaction. Hooke's law is the extremely used in a branch of science. On the other hand, Hooke's law is extremely approximately most solid bodies as long as the force and determination are small injured for this reaction. Hooke's law is extensively used in all branches of science and engineering as is the foundation of many disciplines such as cyclometry, nuclear machines, and acoustic. It is also the fundamental principle behind spring scale, the momenter, and the behind wheel of the mechanical clock. The modern theory of elastic generally Hooke's law to say that the string of an elastic object or material is proportional to the stress applied to it. However, since generally straight and the strain may have multiple independent components, the proportion factors may no longer be just single real number but rather a linear map that can be represented by a matrix of real number. In the general form, Hooke's law makes it possible due to relation between the strain and street for complex objects in terms of industrial purpose of the material it is made of. For example, one can induce that a homogeneous rod with uniform cross section will behave like a simple spring when stretched with a strictness directly proportional to its cross section area and inversely proportional to its length. Thank you friends. Like, share, subscribe my YouTube channel.